Hey guys, Buildzoid here, and today we're going to be taking a look at how I repaired a Sapphire RX 5700 XT Pulse that was donated by a viewer of the channel. And we're just going to skip right to it, because if you want to look at, like, you can find pictures of an RX 5700 XT Pulse on the internet. It's not, like, this was actually, so guess I'll get a little bit into the backstory. So this was a card that somebody was actually, like, benching. So the card was very clean, but it had, well, failed attempts at modification. Or, well, yeah, well, it had one failed attempt at a modification. So the origin of this mess is the previous owner tried to hook up the Elmore EVC2 to it. They had grossly inappropriate equipment to do that. They also chose quite possibly the hardest way to do it, because I am relatively certain these three pads over here are the I2C interface for this voltage controller, so you could have just, connected over here instead of trying to connect to the I2C pins directly on the VRM controller, but, oh well, that's, too late for that. The previous owner basically ripped a bunch of stuff up. Ripped a bunch of traces off. There's also this blob that isn't supposed to be there, and just generally kind of made a horrible mess. So we need to clean that up. And then the card also had another issue, which might be related to this horrible mess, but I'm not actually sure. So we'll get to that as well later. So anyway, step one, we need to clean the area up, because quite frankly, I have no idea what's even going on with this. So to clean it up, I just applied some fresh flux and just heated the entire area with hot air and the soldering iron, and just kind of, use the soldering iron to get rid of the, like, weird blob of solder over here. And so, yeah, so cleaned that up and just generally sort of made the area not a mess, or less of a mess. So, okay, so the tape's gone, the blob of solder that isn't supposed to be where it was is also gone, but I can't actually tell you where things are supposed to be connecting right now, just looking at the card. But luckily for me, Tech Power Up GPU reviews often include close-up photos of the VRM controllers. Now, they're not really meant for, trying to rewire the card, but this works well enough for my purposes. Like, we can see, like, this is getting cut off a little bit early over here for what I'm trying to do, but we have just enough to actually fix the card. So let's go through. So first of all, we have this pin, which we can clearly see connects over here, and then that connects over here, right? So that is this connection right here. So that's all good. We don't have to do anything about that. There's nothing wrong with that. Now the pin next to that is, like, barely even there, but it's still, like, there's still enough that we can connect to it. So anyway, that pin we can see goes all the way over to this resistor, and that's all just gone. That's just gone. There's none of that it's gone. So yeah, that test point is gone. The resistor's still there, but everything else gone. And then we have this connection over here, which goes to there, and very specifically to there. It does not touch either of these two pads. So that's what we need to rewire, because honestly, everything, like, yeah, there's some scraped solder mask over here, but the traces are still there, so we don't have to worry about that. So yeah, and the pin that I actually have to repair, that's this one, right? So that has to go to here. So now that I know where things have to go, it is just a matter of getting some very fine wire to connected to the controller and to where it's supposed to go. So to do that, I use enamel coated copper wire. I think it's like 36 AWG or something like that. It's very thin. Like the specific, I don't think the thickness of the wire is really that important in this application, because if you have functional eyes, you can probably tell if the wire you're trying to use is too thick for the job, right? And in other cases, I've actually just, like, pulled strands out of random multi-strand wires for this kind of thing as well. It's just that some time ago I bought, like, a really big spool of enamel-coated, very thin wire that I like to use for vault modding, and also this kind of thing. It's perfect for this. And the reason well, the nice thing with the enamel coated wire is that if it's touching stuff, it doesn't short out anything. Um, so anyway, how do I get the wire into place? Well, that's very simple. So I use the soldering iron to basically melt the enamel coating off of one end. I don't melt off the other end because then I won't have anything to hold the wire by. I'm not very good at using tweezers to hold wires. I like to hold one end of the wire with my hand and the other end, we just dab at it with the soldering iron. And so for that, I also have to like get this entire area very hot. I have found that because this isn't the first time I've been soldering wires directly to the pins of a VRM controller. And in my experience, one thing that makes this way, way easier is just making sure that the board is at a very high temperature. Because when you're trying to solder wires to pins this small, the biggest issue you run into is the contact area between the soldering iron and the pin is it's the size of the pin. So it's not very large, and that means the heat transfer is really terrible. Which means if the board is cold, the soldering iron is basically not going to be able to deliver enough heat into the solder blob that you're trying to, put your jam the wire into to, well, jam the wire into it. It's just not going to melt, or it's going to not melt quite as much as you want it to. So really best trick I have for doing this kind of super fine soldering is making sure that the board is very warm, because if the board is cold, the soldering iron just kind of doesn't, even a good soldering iron is just going to struggle to actually deliver heat into the pins. And actually, if you preheat the board enough, even a crappy soldering iron can actually do an okay job of this, because yeah, the heat transfer in this scenario is just it's less about having a soldering iron capable of delivering a lot of power and more about there's just not a lot of surface area that you can deliver that power through. So, or deliver the heat through. So yeah, that's sort of the main annoying thing with this kind of soldering in my experience, is that you end up working on a board that you can't touch with your hands, because the board is over 100 degrees, ideally. So anyway, yeah, a lot of preheating went into this, and then basically I hold, I like to use a paper towel to sort of pad my hand off of the board so that I obviously, so that I don't burn myself. So I'll just put down a paper towel over in this area and then hold the wire with my fingers, because I've tried holding wires with tweezers. For whatever reason, if I'm holding tweezers, my hand just applying pressure to the tweezers makes my hand really unsteady, and so the wire ends up wobbling all over the place, and it doesn't work. So I just use my fingers for this kind of thing. Obviously, that means I have to hold the wire pretty far back. So yeah, I'm not gonna, this isn't cut to length ahead of time. I start out with a wire that might be this long, right? Significantly longer than what I'm doing, and I just hold it pretty far back, and then the one end is stripped of the enamel coating, which you can just do with the soldering iron. And I just line up the stripped end with the pin that I want to get, and then I just quickly dab at it with the soldering iron, and if everything is hot enough, that'll actually make a connection. It's not going to be a very sturdy connection, but it's going to make a connection. And from there, we can now, bend the wire to here. And for this part, I actually use the tweezers so that I can hold the wire in specific locations. So with the tweezers, I'd for this, I'd hold the wire over here and then use another pair of tweezers to sort of get it into position. Then once it's in position, hold it over here with the tweezers, use the soldering iron to solder the wire into place, and then just break away the excess. Right? Because this is very thin copper wire, so you can just wiggle it around a bit, and eventually it'll just snap. I wouldn't pull on it. I'm not sure that it would actually be strong enough to rip components off, but I don't really want to test that, especially since I'm already fixing ripped off traces, right? So yeah, so once the wire is in place, I just sort of the red stuff is UV curing solder mask. So put some solder mask over it, cure it with a small UV lamp, and then use hot air to basically clean up this end of the connection, right? Because the initial connection over here is actually quite weak. It's like just enough to hold the wire into place. So use the hot air to clean that up. Which this condition that this is in is after the hot air. I didn't really consider documenting the whole process going through it. You might also be wondering, like, Buildzoid, why didn't you just film it? Well, I don't do this kind of soldering with a microscope, partially because I don't have a microscope, partially because I don't want to, and like, I don't have a microscope because I don't want a microscope. So recording this kind of thing would be kind of difficult. Yeah, so, because like my head would get in the way. It's like either I can see what I'm working on or the camera can. And between the two, between me and the camera, I prefer me being able to see what I'm doing. So anyway, yeah, so that's my method for getting the wires into place, is just sort of tack them down with the soldering iron. Well, make sure everything is really hot, then tack the wires into place with the soldering iron, secure it with the UV solder mask, and then hot air, like use hot air and tweezers to do cleanup. Which will be more obvious once you see the second connection that I'm making, right? So we have this connection is now fixed, but we still need to fix this one. So that one, same process, right? Just run the wire, tack it at the pin, solder it here properly. You can see here where like you can see the break off point over here, and then just secure it into place with more UV curing solder mask. Now, at this point, you might be looking at this and be like, that kind of looks like it might be shorted out. And actually, I don't think it was shorted out, but also I didn't like the way it looked. So, touched it up with the hot air, which actually, this is before touching up. I'm not sure why I have this photo here. Anyway, here it is after touching up. And so for the touch-up, what I ended up actually doing, because that pin really didn't, like, there wasn't really much solder on that pin, or actually either of these pins to begin with. So what I did was apply flux, and actually I have like 0.3 millimeter BGA solder balls, and so I put a solder ball over here, and use that to, because I wanted to get some more solder into the area, because the connection, like, it was very like minimal. So yeah, I put a solder ball into the area, and then just use the hot air to heat everything up. That solder ball was actually significantly larger than what I needed for this, so it ended up bridging these two pins together, but that was easily cleaned up by just dabbing at it with the soldering iron, and then after dabbing at it with the soldering iron, I was left with this. And honestly, I am very pleased with how this looks. Yeah, I think this is a like, for considering how it started, right? Like from this to this, I am very pleased with my work. Very pleased with my work here. So, yeah. Now then, unfortunately for me, this was not the only issue with the card, and when I tried to turn the card on in this condition, it did not turn on. And so we get to the actual front of the card now. Yeah, I tried to turn the card on, it doesn't turn on. This is very lucky for me, or more like I'm lucky that this card has a bunch of fuses, because, yeah, this one had a shorted power stage, as well as the mess around the voltage controller. It's quite possible that the shorted power stage was a side effect of the mess around the voltage controller. I'm not sure, but it's possible, because I don't think the VCore VRM on this is supposed to just blow up for no reason. Anyway, the reason it is, I'm glad this card has fuses, because it just didn't occur to me to check for short circuits, right? Like, you get a card with something like this on the back, and it's like, oh, this is the issue. I don't have to worry about anything else on there. And that was stupid of me. You should always check for short circuits. Okay? Always. Because, like, if the card didn't have fuses, and if the power stage that was dead or like shorted out was on the memory power delivery instead of VCore, that would be really bad. Yeah, because dead power stages will basically short 12 volts straight to their output. So like a dead memory power stage will quite easily kill all of your memory chips as well as your memory controller, and then you have a parts card is what you have. Now, luckily for me, this card does have fuses. In fact, Sapphire, like, put a lot of fuses on here. Like, I don't think I've ever seen another card with a 3.3 volt fuse, right? This one's for 12 volts, but this is a 3.3 volt fuse. I can't think of a single other card that I've ever seen with a 3.3 volt fuse. And then, of course, we have 2 fuses on the 8-pin and a fuse on the 6-pin. So after the card didn't power up during my initial attempt, you know, I went around and just checked the fuses. This fuse checked out as good, 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 bad. These were blown, and there was basically a short circuit on, like, all of these capacitor pads over here. So all of these capacitors, actually not, I'm not sure if this one, but like these 5 power stages were these 5 power stages connect to the 8-pin, and they were all shorted out. Or like not the actual power stages, but their inputs all had a short circuit on them, right? Because these are in parallel, so there's like one big, like if you think about the 12 volts, it comes in, it goes through the fuses, which the fuses are in parallel, so it sort of does this, right? And then it comes back together. It goes through this inductor over here, then it goes through these resistors, which again it goes in parallel, and then it goes into all of our power stages, and that's in parallel. So that does like that. So if you have one dead power stage, it looks like all of them are shorted out. And I think actually this 8-pin might also power some of the memory. So yeah, great big short circuit all over the place. Now, I came to the conclusion that this is probably a V-core short circuit because the resistance that I was measuring from, from like, say, this inductor or this side of the fuses, because this side goes to the 8-pin, right? And the fuses are blown. So on one side, there's no short circuit. On the other side, that's where the short circuit is. So easier to measure from the inductor, in my opinion. So from the inductor to ground, the resistance was super low. We're talking less than 1 ohm of resistance, which means probably a V-core short circuit. Like, technically, it is possible to sometimes get power stages that short 12 volts straight to ground, but in my experience, that is very, very rare. Usually, dead power stages short 12 volts to the output, which is much worse in terms of the amount of damage that they can do if you don't have fuses. But it does kind of make it easier to figure out which one's shorted, because you'll see things like, oh, you check for, like, and unfortunately, Navi being a relatively modern GPU, the core resistance is super low. But if you check, like, say, if you have like a HD 7970 with a dead MOSFET, you'll actually see the resistance of the, like, dead V-core high-side MOSFET. You're actually going to see the resistance of the core on 12 volts. So that makes it super easy to tell which power delivery, like which VRM shorted out, because you can just see the resistance of whatever was getting powered, right? So it's like core short circuit, you see core resistance. You get a VDDCI short circuit, you see memory controller resistance, which would be very concerning because your memory controller is probably dead at that point, but you'd be able to tell very quickly. But anyway, so on this card, we have these 5 power stages that are like, well, one of these 5 power stages is shorted out because the resistance is extremely low, and these power the V-core, so it's probably one of these. Now, my preferred method for figuring out which power stage is dead is to simply lift the inductors, because the main problem that you run into is that the inductors are also all in parallel, right? Like, they all connect in parallel on the output side, so there's no way, like, you need to, like, disconnect the power stages, basically, to figure out, you need to disconnect the power stages from, like, either the 12 volt side or the output side to figure out which one is shorted out. And you can lift inductors. Tilting power stages isn't really a thing. Technically, you could desolder them, but that, like, with hot air, but that's not really fun to do. And the power stages are much less, like, robust than the inductors, right? Inductors are basically a very fancy piece of wire. Power stages are actual, like, silicon. So, these don't handle heat cycles quite as well as inductors tend to. So my preferred method is to just lift the inductors and then check which of these paths is shorted out. So yeah, and I ended up lifting all 5 of these because this is the actual power stage that was shorted out, but I ended up lifting all 5 of them because when I was lifting them, I didn't lift this inductor high enough, and so the short didn't go away. So I thought I lifted this one up a little and it was still like there was like a solder bridge from the inductor to the actual pad. So it was still connected and I didn't notice that. Um, and so I was like, oh, the short circuit's still there. Let's lift another inductor. And once I lifted like all 5 of them and I'm like, why is the short circuit still here? Like I lifted all the inductors. This doesn't make any sense. Um, so then I lifted them some more. And once I lifted them some more, it became really obvious that, like, yeah, this one, no short, no short, no short. Like, these were all good, and this one was bad. So this one, like, you measured from here to here, and it was like 0 ohms, right? That was a 0 ohms. Whereas all of the other ones read some, I think, I don't remember. It wasn't 0. Like when you're looking for short circuits, like if the short measures as 0 ohms, right? Originally, like very close to 0. And so as long as the other power stages are reading anything other than that, good, as far as I'm concerned. So yeah, this one read basically 0 ohms or like 0.5 or whatever, right? Like something really low. And so it's like, okay, this is the dead one. And so at that point, I resoldered all of the inductors except the one for the dead power stage. That was just sort of like a visual reminder for which power stage I need to desolder. Masked off the capacitors, right? Because I have made mistakes like desoldering the wrong component in the past. But yeah, masked off the capacitors to sort of protect them from the hot air a bit. Because, yeah, polymer capacitors, pretty tough, but they really don't appreciate getting blasted with hot air for extended periods of time. That tends to cook them. And, like, they won't necessarily short out, but they'll stop doing capacitor things, which is bad. Though, to be fair, they are very redundant, so it wouldn't really... Like, I wouldn't... Like, if you cooked one of these capacitors, I don't think it would render the card non-functional, but you know... don't really want to be doing that. So anyway, mask the capacitors off, and now we just hot air off this power stage. Unfortunately, I don't have replacement SIC 620A power stages, so for now the card is just running without the power stage, which is a thing that works a lot of the time with many GPUs. Yeah, a lot of VRM controllers are perfectly capable of functioning even with one of the power stages removed. Now, the other thing that I had to do was replace the fuses because, well, they were blown. And that sucks to do because these are polymer fuses. I think these are called polymer fuses. These suck to desolder because they like smell super bad. So yeah, but yeah, so hot aired those off as well, and then replace them with some 10 amp fuses. So yeah, also these 10 amp fuses are like not quite the right size for these pads, but whatever. We can just blob a bunch of solder on there to make it fit. So yeah, and the card now works. So basically just clean up this mess and turn it into this, which is less of a mess, and then remove the dead power stage. I do eventually, like, I would like to actually replace that power stage. It's just, I'm not sure, like, well, I need to order replacement power stages, so I'm not entirely sure when I'll actually get around to doing that. But yeah, for now the card works without the power stage, and actually to prove that it works without the power stage, ta-da, it's been running, Time Spy over here for a while. As you can see, 5700 XT, Sapphire. Yeah, I do have the fan speed cranked pretty high because I really, like, with one of the power stages from the VCore VRM missing, I don't think, like, going from a 7 to a 6 phase isn't really a huge downgrade, but I would prefer it if, you know, like, I don't want to unnecessarily stress the remaining power delivery components. So yeah, at least until I put the 7th power stage back on again. But yeah, so card works. Not sure what other... Wait a minute, give me a second. I might be able to... Is it going to show up? Ah, yeah, there. Yeah, horrible camera angle. Didn't occur to me to set this up. But yeah, that's like you can tell it's a Pulse 5700 XT. So yeah, that's just been happily running Time Spy here. So, oh, I guess I could show the system like turning off. There. So, yeah, card's fixed. Or, well, card's in functional condition. I don't really consider it fixed until that missing power stage is back on there. But it does work. So, yeah, hopefully you found this somewhat interesting, if not particularly useful, and Windows just decided to close all my windows because I was dragging OBS around, so that's, thank you, Windows, very cool. But yeah, hopefully you found this interesting and maybe helpful. And that's it for the video. So thank you for watching. Like, share, subscribe, leave any questions, questions, suggestions. Is that it? I've forgotten how to do my outro. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. There, I remembered. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, Teespring store, Bandcamp, links in the description. Would be appreciated if you'd check them out. And yeah, that's it. So thanks for watching, and goodbye.